Hey guys, so in this problem we're taking a look at using a hypothesis test to check and see whether or not we can answer this question, which is there evidence to suggest that there really is a such thing as a home field advantage? So basically what this is kind of pointing out is there's this belief that home field advantage is given in sports whenever a team's playing at their home field or their own stadium. And what we did is we see that they've provided us with evidence of the 2007 Major League Baseball season, and that there was a total of 2,431 regular season games. It turns out that the home team won 1,319 of those games, or 54.26% of the time. So the question is that really justification to believe home field advantage? So the first thing we need to do is we need to say, okay, if we assume that there is no home field advantage, then that would mean that our proportion would be equal to 50%. Now, if we're going to believe in the alternative hypothesis, the alternative is that there is a home field advantage. Well, what would that mean for the percentage of games? It would mean that the percent of home games that are won would be bigger than 50%. So these are our two hypotheses that we're going to operate off of. Now, in order for us to first move forward, we need to check all of the requirements here. So the first one is, well, is this random? Well, we can't really pass the random test. So basically we have to say, okay, well then, here's another test. Is this representative of a typical season? And there's nothing in the problem that says that this was an atypical season. So we can go ahead and say because this season is representative of any other season, it's okay that it's not random. So this actually is still going to pass as a random check, even though it's not technically random. The next thing that we're going to take a look at is we're going to say, okay, well, if we think about the success and failure rate, based on what I know, we use the null as the test here. So 50% of these 2,431 games, that's what we would expect. So we would say, okay, if I take the 2,431 games, I know that 50% of them should end up being wins or home field wins. So when I do that calculation here and I do 2431 and I multiply it by 0.5, I get that that's 1,215.5, and then these are successes. And then if I were to do the calculation again, I would get my failures. Well, because it's a 50-50 split, I'm going to get the exact same math. So that would come out to be another 1,215.5 failures. And the important part is that these two successes and failures have to be at least 10. And that passes. So now the last check that we have to do is the 10% rule. So 10% rule. Taking a look here, I can say that the 2,431 games are less than 10% of all games played. And that would make sense. I mean, baseball has been going on since the 1950s at the youngest. I mean, it probably even goes further back to the 1930s or 20s. So it's safe to say that this one result of games is definitely going to be less than 10% of all games played. So we can say we've met all the requirements. So now that means we can build what's called the null model. So if I look at my null model, the idea of the null model is that we're going to have the center located at the 50% because that was our null hypothesis. Now the standard deviation of the null model is going to be the square root of our Q and P for the null over N. Well, taking a look at that, that means that I'm going to get the square root of 0.5 times 0.5 because it's 50% for both P and Q. And then all of that is going to be over the sample size of 2,431 games. So I'm going to do 2,431 games. Now, taking this and taking a look at what this is once I do all my calculations, I get that the total value here is going to be about 1.01%. So now, if I draw a quick picture here and make my normal curve, we know that right here in the middle is going to be 50. And then as I move in these directions this way, I'm going to kind of have to cram this in here, but this is going to be about 51.01%. This is going to be 52.02, and then this one's going to be 53.03. And I'm not really going to worry about what these numbers out here are because, again, what we were worried about is where is this 54% that we actually see right here from the sample data. So coming down here and plotting where that 54% is, that would be one more full step this way. And this is the 54.26% that we need to test. So basically the idea is I need to see what's the probability that this is occurring. So basically, what is this? What's this red color here? But knowing how my calculator works, that really means I need to find this blue color that's all the way over here. So we'll figure this out here in a moment by using the calculator and saying, okay, looking at what I need, I'm going to go into my normal CD mode. And inside of my normal CD, I'm going to type the following. Lower equals 0, upper equals 54.26, my standard deviation is 1.01, and my center is equal to 50. Now, when I do that, what the calculator gives me is that this blue section is 99.99% of the overall data. Well, that means that this red section right here is going to be 0.01%, basically. So this right here in red is really what I was after. So taking all of this, that's going to be the p-value that I'm going to use to convince myself that this is actually sufficient evidence. So what we can say now is because this p-value is so low, we have enough evidence to support the alternative hypothesis. So we would say with a p-value of 0.01%, there is evidence to reject, very important that we talk about rejecting the null hypothesis. So the null hypothesis and that the proportion of home team wins is not equal to 50%. Now, the one thing that we have to be careful of is that we've only said that we've rejected the null hypothesis. That does not mean that we've proven that the alternative is true. It just means that we can definitely say that the null has been rejected. We can't really say anything else, and I just realized I misspelled reject right here, so let me redo this. Reject. So make sure that you're always phrasing it in terms of the null hypothesis, and it is a fairly lengthy process. You're always doing this picture that we drew right here based on the null model. So always do this based off of the null hypothesis, but your p-value is always going to be based on where does your alternative hypothesis fall within that picture.